Okay. All right, so thank you everyone once again for coming. So today we're going to work through a couple basics of SPSS, and today is going to be really the basics. So we're going to talk about how to use SPSS, the different options you can do to view variables, enter variables, and we'll talk about some descriptives as well, how to look at really your first pass and looking at your data, how to make a couple basic graphs. So this might be too basic for some of you, and the next week what we'll do is really go into, is this going to work? If we're going to, yeah, okay. We'll go through different types of analyses, including associations among variables like correlations, regressions. We'll also on week 3 talk about group differences, so looking at t-tests, for example, and ANOVAs. And then in week 4, I'm using week 4 as a little bit of a spillover time because last year week 3 took quite a while. And also I want to go through something that I'm adding this year based on feedback from last year is a little bit of a flow chart type of things to decide what type of analysis to apply to your data or to answer your research questions. So if you have been in last year's version of this, the first 3 weeks will be very similar. Week 4 is going to be a little bit different. Okay, does anyone have any questions before we start? Okay, thank you, Andy. We have some extra slides. I can send out slides as well for anyone who's still missing them at the end of today, and of course the recording will be available somehow. I'm very not technologically literate, so Whit will help me pass this around, I'm sure. Okay, so before we get into it, I'm going to be going back and forth between the SPSS slides, the SPSS program and the slides. But if you follow along on your slides, you should have most of the screenshots of the things I'll be talking about. And I want to orient us a little bit to the data set that I'll be using. So we'll have an example data set for us to use. And this is data that was collected from 56 children and adolescents. Some of them were part of our control group in this study, and the others were patients with epilepsy. So this is a study that's ongoing in Dr. Nelson's lab. And they came in and they did 2 emotion recognition tasks. They did this in the scanner, but we're not going to talk about any neural data today. We're just going to be looking at their behavioral accuracy on these 2 tasks. So the tasks, we first had them look at different emotional faces, not these, this is a Google photo of it, but emotional faces and decide what emotion the face was conveying. And they did the same thing, but now instead of faces, they heard emotional voices. Okay, and so from this, I have put together a measure of accuracy for each of the 5 emotions that were in the task. So we have happiness, fear, anger, sadness, and neutral. And so this is just the context for the data that I'll be using to go through the different examples. Okay? I'm going to move through this pretty quickly because we have a lot of ground to cover, but if there's any point at which you want me to slow down, repeat, clarify something, please jump in. And if I can't see you, just holler. Okay? Okay, so first things first. Let's open SPSS. Okay, so here we go. There we go. All right. So there are 2 main windows in SPSS that we need to concern ourselves with. We have the data view and the variable view. And you would toggle between both by using these tabs at the bottom. So data view is basically where your data resides. So each person is a row, in this case, and each column is a different variable. So we'll see that ID number over here, 1002, has their date of birth, their testing date, their age, their gender, group, etc. Okay? There are other ways to set this up, but if you're most of the time you want to have a setup where your people are rows and your variables are columns. Okay? Now, on variable view is where you have a list of variables that are describing each of the variables that were at the top. So everything that's up here, if you go into variable view, now each variable is a row, but the columns are not people. The columns are information about your variables, okay? So the first column over here is the name, so you call it something. You can widen it to see over here. The one rule is that you can't have spaces in it. So let's walk through what I have. I have the ID number, date of birth, testing date, age, gender, group, and then I have what I was describing, face task. This is H for hit rate in our lab. Happiness, fear, anger, sadness, neutral. The same things over here for voice. Okay? You can ignore the rest for now. Now, you'll notice no spaces. Over here is the type of variable. Okay? So if you click on here, you'll see these little 3 dots open up. Okay? Whenever you see a dot, it opens up a little menu, and you have your variable type. So you can have it be numeric, which is most of our variables will be numbers. You might also want it to be a string. So if you have text that's being entered, you can put it as a string. If you try to enter text like a note that you wanted to put with each person, or if they wrote in something on a questionnaire, you cannot do it if it's numeric. Your SPSS will just leave it blank. The other common one might be date. So if you were to click on date, you can select the different format. Now notice that you could enter the date as a string, right? Just take it as text. However, as you'll see as you'll see today, you might want to do things to manipulate your date, calculate differences in time between two dates, and in order to do that, you need your variable to be in the correct format. So it's worth taking the time to set up your variables in the correct format. Okay, so let's keep it as numeric as it is. Over here you have width, which is how many characters are going to appear. So over here, you need enough characters. Essentially, if you have a string variable that's very long, you want to up this to like 100, 150 sort of thing, okay? Decimals is the decimal points after, so it's a little bit related to width, but not really. So decimal points, you can increase the decimal points past 2, like these are continuous variables, and they are being shown with 2 decimal points. Sometimes you'll have, we have things like the amygdala, the ratio of the amygdala volume to the head volume. Those are really small values, so we need like 8 decimal points sometimes to really see meaningful differences. So it'll be 0.000 something. So you can change this to view your variables in a way that makes sense to you. Label over here is basically a more detailed name for your variable. So sometimes you might want to specify what exactly these variables represent. So DOB, I had it as just a acronym here, but you could say if you were sending this to somebody else, for example, a data set that you were wanting to share, this would be a good place to put a description of your variable. So let's say for age, I might want to add it's in years. So I'm going to specify that this isn't in months or days, that this is in years. Okay, very important to annotate your variables, especially when they have names that are only comprehensible to you. However, be aware of the fact that any label that you put in is going to be the variable name that appears in your output. Okay, so if you make it too long, like the entire item on a questionnaire, that's fine, but when you ask for the means of that variable, you will get in the output the entire label. So, trade-off between clarity and brevity. Okay, the next here is very important. It's called values, and this is another one where if you hover over, it gives you some options here. So here, I'm going to use gender as an example. If I click on this, this is going to tell me that 0 is female and 1 is male. So this is assigning values to your numbers. Now, some of you may know if you have a dichotomous variable, you want it to be 0 and 1 usually, just in terms of calculating things a bit better. So you might forget though what 0 stands for and what 1 stands for if you don't label your values, right? Again, this is especially important if you're sharing data across labs with other people. Gender is one where people nobody has a consistent classifying strategy for this. So I'm going to reset it to show you how to put it in. Okay, so can you clear? No, apparently not. You cannot clear this. Hey, okay. All right, so when you start up setting up your variables, this is what it'll look like. It'll say none. So to set it up, you can put here the value. So we had a 0 for female and the label in the second one. You have to click add to make it appear in here. If you click OK, it will not save it. It's just one of those annoying things. And then we'll do 1 male. Why is this happening? Okay, I can't type today. Add. Okay, if you wanted to change it, if you decided that this wouldn't make a lot of sense, but if 3 were to be male now, you'd have to click change. So essentially you want to make sure that whatever's in this window is appearing before you click OK. All right? If you wanted to remove it, like I did earlier, just click remove. Does that make sense? So far so good? Okay, moving along. Oh, see, this is a nice little example of what will happen. I hadn't added it, so it's warning me. So I need to add it, and then click OK. Okay? Now, missing variables is the next key here over here. So if you are doing data entry as you go, you're still collecting data, the study's not done, but you're adding it into SPSS, as most of us would do. You want a way to differentiate between what is missing data and what is simply not entered yet. Okay, so on the slides, you'll see a little example of what the empty, it's on page 3, what the empty sign looks like. So if we were to exit this for a second, go back to data view, anything that has a dot, I don't really have any missing. Say I were to create a variable here. Anything that has a dot is empty. It is not 0. 0 is not missing. As you know, 0 will be counted as a 0. So the blank is a dot, essentially. So you don't write anything in here. You don't put a comma. It just looks that way. If you wanted to check that it's actually blank, you up here have the value. You'll notice too, if I click on here, it says 39 because I have it set to decimal 2. However, up here it gives me the full value. Okay, so if you're ever not sure what the cell contains, go up there. Okay? So I'm actually going to get rid of these for now. Okay, so back to variable view. Over here, if I add in missing, I can either say no, I don't put anything, or I can say, okay, you know what, anytime you see 999, for example, that's a common one, treat this as missing. Don't count it as 999. If you don't set missing values here and you put 999, it's going to count it in the mean, so your mean is going to be like 400 something as opposed to a value between 0 and 1. So you can select 999. If you have different types, you can specify up to 3 different types. And sometimes, what we'll do in questionnaires, we'll have a code for that person didn't do this questionnaire versus that person skipped this item. It could be 889 or 998 instead. So you have different types of missing values. You can tell SPSS, here, treat all of these as just missing. I need to know as the experimenter how many times it was a missed item versus a missed questionnaire, but for analysis purposes, these are all missing. If you had more than that, you can say, all right, anything between 900 and 910 or something, it would be counted as missing. I recommend using numbers like 990 to 999, something like that, or one discrete value. Does that make sense? Okay. So I'll add this in. No, I don't think we have any missing here. These can not super useful. Over here, your measure. So at the bottom of page 3, I have this written out for everybody, but essentially there are 3 things to choose from. So you have a nominal variable, and it's represented by these little non-touching Venn diagram sort of thing. That is a category where they're different categories. They're categorical variables, but there is no order to them. Like gender is a great example because we're not assigning value and we're not saying that 1 is bigger than 0. These are just ways that we're differentiating the variable. You will have also ordinal. So this is a case where we are differentiating the variable. 1 is bigger than 2. So sometimes people will use that for income brackets, like there's an order to it in increasing order, or for Likert scales. Likert scales are a good example of ordinal data, so you want to specify if that's what you're entering. And then scale is kind of the catch-all for most continuous variables, and that will sort of encompass all the other types of continuous variables, whether it's interval, ratio, or discrete variables. They all kind of go into scale. Okay, so you want to go through, whenever you add a variable, as you'll see in a second, this will be empty most of the time, and so you want to make sure that you're specifying the type of variable that you're using. Okay, how are we doing so far? Good? Okay, so very quickly, I'll go through how to add new variables. So if you, where's my mouse? Here it is. If you scroll down here and just start typing, new variable, well, it can't have a space, but there you go. It'll sort of fill in some of the things for you. Okay, so you can just type in new ones. You can copy in from Excel. Other ways of doing it, if you wanted to insert something up here, you could right-click on the numbers, insert variable. Okay? And then you would go through and fill them. You could clear it by clicking on that number and writing clear, so that's going to delete that variable. And if you wanted to move it around, you could grab it and then drag and drop. So you'll see that little red line. Can everyone see it? Okay, say I wanted to put it right before my accuracy variables. There it is. Okay, sometimes it just makes more sense to you. It really won't change anything in the analyses, but it's just for your purpose of organizing your data. So if we go into data view now, the same categories and same principles will apply. So you would right-click on these numbers to insert a case if you had a new participant. You can also just type them in at the bottom. And very similarly, if you wanted to grab somebody, I'm gonna clear them. If you wanted to grab someone and move them around, you could. Okay. If you right-click up here, you can do insert variable again. But if you do insert variable up here, you'll only have this kind of non-name, and then you have to go to variable view and set it up anyways, right? To do that, you can either just flip back, but if in a case where you have thousands of variables, is a crazy big data set, you can double-click, and it will bring you to that variable in the other tab. All right, and same thing, if you're in this tab over here and you wanted to see their accuracy for voice happiness, and you double-click, it will bring you to that column. That's especially helpful if you have really big data sets. Okay, good so far? All good? Okay. The other way you can move data, so you can manually move just one person or one variable if you want to, but you can also sort by a certain variable. So I didn't walk you through these very well, but group, for example, what we're doing is 0 is control and 1 is epilepsy. Okay, so if I wanted to say, see all of my people, all my control groups in one section, and then have it sorted different. Again, this is really just for visual purposes and organization. You could go into data, sort cases. You can also do sort variables, but in this case, where variables are the variables, cases are the people. And you want to sort by group, for example. So what's your variable that you want to be sorted by? Decide if it's ascending or descending. And then you can click OK. You can also save a file with the sorted data. Again, this is really going to be useful if you have a really big data set and you have tons and tons of people and you want to send it to somebody and have them sort of orient to it better. But in terms of analysis, it's not really going to make a huge difference. Okay? So I'll just show you what happens. The syntax comes up. It logs what we're doing. Not syntax, sorry, output. It's logging what we did. And now I have all my zeros and all my ones. Okay, so that's can be helpful. All right, so that's pretty much it for the navigation part. I'm going to talk a little bit now about recoding variables. Before I move through, does anyone have any questions? So far, so good. Okay, so recoding variables can be interesting if you're trying to do things like recode items on a questionnaire. You know how you have some that are reverse coded and you are entering it as it is in the questionnaire, but then later before your analyses you want to reverse code some items because they're worded like in the other direction, and then you want to put them in a total. Does that make sense? Like things like that. You might have a case where you initially coded something in 5 categories, like in epilepsy we'll have frontal, temporal, occipital, generalized, unknown, juvenile myoclonic epilepsy, but then you decide in your analyses you really want just frontal, temporal, other. This is the type of thing that would be helpful. So instead of manually going in and deciding, okay, now if they were juvenile myoclonic epilepsy, now they're 3 for other, you can just do this automatically, okay? So to do this, you would go into transform, and then you have 2 options to recode. Recode into same variables or recode into different variables, right? I'm going to walk you through same variables. However, I would recommend most of the time doing different variables. The reason for this is, say let's take the example of the recoded situation, right? You have item 1 needs to be recoded, reverse coded in the other direction so that 1 is now 5 on the Likert scale and vice versa. And you've done that, you recoded into the same variable, but now you've added people. How on earth will you know if you've done it for the new people or not? Right, there's no way to know if you've applied the recoding and when and who has the recoded. And now if you wanted to do it for the new people, you can't, right? Because now you're going to flip everybody back. So I'm going to show you both, but I would recommend that most of the time you use recode into different variable, and then you give it a name like _RC for reverse coded or something like that to differentiate who has that and not. Now if you do that, you'll see that the new people that you add won't have that variable in because it's something that you had to compute yourself. It's not something that you entered manually, and that way you'll be able to track. I can just rerun the recode on the original into the new, and we don't have any issues with that anymore. Does that make sense? Okay, so recode into same variables, I'll show you anyway. So let's say instead of 0 and 1, I wanted it to be coded as 1 and 2. Okay, there's not really, I don't have a rationale for this, but let's just go with it. So I'm going to recode, this is the variable that I want, and I'm going to choose the old and new values for it. And so here on this side you have all the old values and the new values, and you have one of those sort of menus that are here to, like we did when we were entering the labels, keep track of the changes you're making. So old value could be 0, and now I want it to be 1, right? I can do add. Now it's a 0 to 1. Old value 1, now I want it to be 2, add. If you're doing something where you're doing 1 is now 5, 2 is now 4, because you're reverse coding again on that scale, and 3 is now 3, you have to write 3 and 3 and add it. Okay, there has to be something, or else it's just going to skip the 3's because it doesn't know what to do with it. So even if a variable stays the same in this change, you have to put it in. Okay. So you'll also see other options here. So you can have anything that is system missing, which is anything we've defined as missing when we did that whole 999 business and said that that was considered a missing label. Now you can say anything that's system missing, give it a new value, or vice versa. Anything that has this value, consider it system missing. So if you had 999 but you just didn't specify that that was missing, now you can. Okay? You could do a range, so kind of what I was talking to before when we had a coded variable that had 6 categories and I want to reduce it to 3. Anything that's 3 to 6, I want it to be called 3 now, because I want it to be in the other category. This is a good way to do it also, as a range of data. Okay? Does that make sense? And then you would click, well, let me go back to this. Click continue, and then click OK. However, and I'm going to make a really important PSA for this, use syntax. So who knows what syntax is in this? A couple people. Click paste instead of OK. Now it should load up. I'll see if I can drag it and bring it to the side of the screen. Here we go. So this is the SPSS syntax. Now sometimes people kind of feel like I don't really know how to code. You have no need to know how to code to use the syntax in SPSS. What SPSS does is we've been clicking through the GUI, the graphical user interface. We've been clicking through the windows, and then what we can do is say paste, and it transposes what we've clicked through to a coded version. Now, this is useful when you want to keep track of what you've done. Okay, so if you are showing your supervisor what you've done, you had this really long click-through session where you had to put a bunch of variables on and you don't want to redo this every time you need to rerun this analysis, save it, right? If you have a series, like a process where in order to compute this variable you needed many steps, save it so that you're not having to click through every single time all of the things. So this is a great example of recoding data. If this is something you're going to have to be doing on the regular, again with that reverse coded example, just save it as the syntax, and then what you can do is that you can reopen your syntax, highlight what you need to do, and click press the go button, and then it's done. It happened. I mean, it's in the other window, I'll show you, but this is a really, really valuable tool in SPSS and will save you hours of time, right? It's also a really easy way, as you'll see later, to do a bunch of different analyses. If you have many regressions to do, for example, and they're all sort of on the same variables, but one is a little bit different, this is a much faster way. You can just go change the name of the variable. Say I wanted to do the same thing for gender now. It's the same, I want to apply the same analysis or the same recoding. It's done. I don't have to go back into my windows and click and move over gender and go through the whole 0 is now 1, 1 is now 2. This is just a much faster way of doing things. Okay, so if you anticipate that you'll have to redo this again, and even if you don't, honestly, it's just good practice to use syntax. So remember to click paste, and then you can save your syntax as you go. I have many little syntaxes, I don't know what the plural is of that, documents of syntax saved for different ongoing tasks. Like I figured out what the equation should be to, apply an arc-sign transformation to my variable. I'm not going to find this every time, right? I'm just going to save this in my syntax. I don't remember it by heart at all. I just use the syntax. Okay? Have I convinced you? Okay. So now if we go back to here, then you'll see what everyone before was 0 and 1, and now they're 1 and 2. Okay, so it's just to illustrate this. I'm going to click through the first steps of recoding into a different variable because it's a tiny bit different. So if I wanted to do what I, suggested that we do and recode something, basically you have to move, say, age in years. I don't know, that doesn't make a lot of sense. Let's use gender. Gender into this little window. Okay, so here it said input variable to output. Input variable. Now output variable is going to be over here. So I don't know, it doesn't make a lot of sense. Name it something. You can give it a label or not, and then you have to click change, so it comes into here. Right? All of these menus, whenever you see that, you have to basically see what you wanted to do before you click OK. Now, then you click into old and new values, and this window is the same. Okay? Are y'all good on recoding variables? This is something that people end up using a lot when you're preparing data before you analyze. Okay, just making sure I've covered everything over here. Okay. You didn't miss anything. All right. So good? Let's now compute a variable. So we just recoded things. We just gave new values to, where's my mouse? New values to old values. But what if we wanted to actually create a new one? Okay, so I cleared it earlier. I kind of gave away the punchline. But say I wanted to get an average accuracy for all of the different emotions, right? Currently I have it listed as happiness, fear, anger, sadness, and neutral are all separate, right? But what if I just wanted one value? I want to create an average score. Okay, I can do this within SPSS. I don't have to move to Excel, compute the mean, and come back, right? So to do this, you do transform compute variable. This is a super important and useful function. I'm going to show you a couple different things that you can do. Okay, you can do averages, you can do sums, and you can also do transformations. I mentioned an arcsine transformation for proportion data. And you can also do dates, like calculate the age in months, for example. So you have their date of birth, you have their testing date, how old were they in months. You can do it within SPSS. I usually, before this, would go onto Google and date calculator and enter it. This is much faster. Okay, so here you have your target variable. So I just said I wanted to create an average of the face accuracy. Okay, so I just named it something. Over here is the numeric expression that I want to use. So all of them are here, although a lot of them I've never used, to be honest with you. The common ones I've listed in these slides. So there's things like exponent or square in the arithmetic section over here. There's statistical that has, max, mean, things like that. And then there's date arithmetic for what I mentioned, calculating the dates. So I'll go through just the mean, for example, right now. So you could compute mean, and now I want to move over. Actually, here, I'm going to show it the right way. Statistical mean. Okay, down here, if I click on this, it'll tell me how I'm supposed to set this up, right? Eventually you start doing it from memory. It essentially says, okay, mean, open bracket, whatever your expression is, comma, whatever your expression is, comma. So basically it's telling me this is how I'm going to set up my variables. So I want happiness, comma, fear, comma. All right, does this make sense to everybody? And close with a bracket. Okay, paste, super important, paste, right? Now it's over here. Now another example of why it's important to paste is that if I wanted to do the same thing, but now for the voice, I don't have to click through it, I can just come in and change this, right? And you could even do find and replace. I think that it's a little bit clunky, the find and replace function in SPSS. So if it's, only 5 variables, usually I'll just do it one by one. But if you have a really long syntax that you're changing, you can use it. You can also,
up so we can see it.
Oh, I'm so sorry. This is it. This.
Oh, the find and replace though.
Oh, sure. Where is it? It's in, I think it's just Control F. Yeah, Control F. Just like in Word, to find and replace. I don't find it works super well. I find sometimes it makes mistakes. So if I do have a really long syntax, I usually put it into Word and then copy it back. So I think it's just a little bit more accurate in Word, and you can do more fancy things like the two brackets in Word or find match cases a little bit. I haven't had a lot of success with the SPSS version, but you could. And in Word, the thing that's nice is you can select a portion of it to find and replace in, and you can't do this in SPSS. So use Word and bring it back in. Okay, so now I have both. I can run both. Go. And they will appear at the end. All right. You see some of them have missing data because this person didn't do that task. Okay. And you should always just eyeball them. Okay, like your resulting. Sometimes something went wrong. There was a typo in a variable. You have this column that's empty. Just kind of look at the resulting variable. Okay. I'll show you date diff. So reset this. Now say I want their age in months. Okay. In date arithmetic, we'll do the same thing. We'll find it's called date diff, and then here it describes it. Calculates the difference between two date or time values and returns an integer. All right. So date time 2, date time 1, and a unit. This is the sort of structure to it. So date diff. Date time 2 will be testing date, right? It occurred after the DOB. And in two brackets, I can write years, I can write months, because I said I wanted months. I can write other things. And if you go down to the bottom, it'll tell you here what you can do. Enclosed in quotes, years, quarters, months, week, days, hours, minutes, seconds. We don't have hours, minutes, and seconds in our date. Right? So if I went into the date variable like I did at the beginning, the type of variable, and I selected date, and then I went down to one that had the time, then it would be able to do this. If I try this now, it's going to be like, what are you talking about? You have no hours, minutes, seconds. Yes?
Is it case sensitive?
For this?
Date diff and you all put it in?
I think yes. I haven't tried it. I always just do it as this way, but good question. Okay, I'm going to paste it because I've been preaching, and now I'm going to run it. So if I go back to here, I should have at the end a variable called age months, and I can use that if I need it. All right? I think that's all for computing variables. How are we doing on this? Any questions? No. Okay, moving on briskly, I know. But we're going to talk about descriptives and frequencies and crosstabs and stuff like that. So now that you've prepared your data, it's entered, you've recoded everything you needed to, you've saved all that beautiful syntax, now we want to take a look at first pass. We're not even going to look at associations among variables. We just want to see how many people we have in each group and is our coding of variables correct. So this is a little bit of a quality control as well as the descriptives. Okay? So first things first, descriptives. If you go into Analyze, Descriptive Statistics, and move it over to Descriptives. This is to get things like the mean, a sum of different things, the standard deviation. Oh, this is weird. A little menu popped up on the screen. Come on. Okay. And then you can get different information about it. So let's say I want to know what the average age is, and I want the gender descriptives, and I want to know, say, I don't know, let's not use this one, let's do, yeah, sure. Their accuracy for happiness in the face, which, by the way, the median is 96% in Western civilizations. So if I have really low value, I might have some questions, right? So over here, I have options, and then I can click what I want. So these are the default that'll come with. So if I didn't click anything and I went straight to OK, this is what it would give me. But you can click other boxes if you wanted a sum. Doesn't make a lot of sense in this case. Standard deviation. Here you have your normality of the distribution sort of characteristics. So kurtosis is how pointy your little peak is, and skewness is how centered or not your little bell curve is. So if you wanted to assess these, that's where you would go. So I'm going to click continue. Click, and if you wanted to save a standardized version of it, like a Z-score, this is where you would click. Okay, so now it'll come up in the output. And this is what it'll look like. So last year I managed to make this super big, but not make this any bigger, so apologies. But it should be in the slides if you wanted to see the details, okay? So here it'll just give us the descriptors that we asked for. We have all of the variables listed here. We have the n, the minimum, the maximum, the mean, and the standard deviation. So our kids are between the age of 8 and 20. Their average is 14 years old. Their gender doesn't make a lot of sense, right? So note, mean is not really useful for binary or nominal variables in general, right? All we can glean from this is that they were slightly more female because it's less than 0.5, right? And we'll get around to how to fix this after. But basically their average is 76 accuracy for face happiness. So they're not doing super well on the task. You'll notice here the N. So I have 57 people in my list here. 57 for age, 57 for gender, and 55 for happy. That means that 2 people didn't do the face task. Now, I know this, but you can validate your data this way, right? So if you're like, no, everybody did everything, I have no missing data, and one of them is here, it might have been coded wrong, it might not have saved the way you thought, there may have been some mistake in the data entry, so this is a good way to sort of check. And then you'll see, because SPSS's default is list-wise deletion, which means if someone has missing data, get rid of the whole thing, they will list valid list-wise as 55. But you don't have to freak out about any list-wise missing people. It's just mostly, as long as it matches what you have in your data set, you're good. Okay, what to do about stuff like age, gender, right? Oh, I think I forgot to show you something. Nope, I didn't. It's on the next slide. Just want to make sure I'm not skipping over anything. Okay, so now we want to know, okay, instead of telling me the mean gender, like that's not really helpful for me, I want to know how many were identifying as female and how many were identifying as male. In this study, we have a binary gender variable. So we would go into Analyze, Descriptives again, but this time we're going to click on Frequencies. Again, it's popping up on my screen. Over here, come over here. Okay, so I'm going to do age and gender again. So I'll do age because you can still do it for continuous variables. If you have continuous variables that have many, many different values, it's not going to be super helpful. It'll just give you one long table that has like 0.06, one person, 0.067, one person, right? Like that's not going to be super helpful for you. But for things like age where it's between 8 and 20, we're probably fine. So you can go back into statistics again, you can get quartiles, you can get standard deviation. These are all going to be the same as in your descriptives. But you can also do charts, and this is very helpful. So you can have it displayed as a bar chart, you can have it displayed as a pie chart. Sometimes it's nice to have it as a histogram because then you can ask SPSS to just show me what the normal curve looks like so I can at least visually assess whether my data is approximately normal, right? Just as a visual check. All right, if we click through other things, I mean, no. These are just small things that you can explore, but they're not really helpful. Okay, so it'll come down here. So first it gave me the age in years. This is the frequency table, this is the value, and this is how many people, right? So I have one 8-year-old and one 20-year-old. Everybody else is kind of in the middle. This column is sometimes helpful if you're reporting things in a paper. So, I can see that 49.1% were 14 and younger. So if, for gender, for example, if we come down here, cumulative percentage will be the same as percent because there's only 2 variables. But if you wanted to say, well, 93 of them were less than 18 or younger. It depends on what your variable. It just didn't make a huge amount of sense in this case, but it can be helpful. And then over here we have our frequency, right? So we have 33 and 24, which is equivalent to 57.9% female, 42% male in our sample. Okay, so these are just really broad pass looks at our data. And we have the histogram. So it gives you these different bars on the curve on top. It's not bad. However, you'll notice there are no 13-year-olds in Columbus. In all of our studies, it's really weird. I don't know if anybody else is working with 13-year-olds and have tons. Send them our way. We cannot find them. But essentially, this is kind of what our distribution is looking like. And I'll take a second to just click through the chart editor with you. So on the slides, you'll have the image of the original default settings for SPSS, and as I understand it, it's a little bit different from the new versions and the old versions. Sometimes they change. The original version is this kind of like putrid yellow with a gray background. I just find these are the ugliest graphs ever. So you can change them, and this will be especially important if you're making one of these graphs for paper, in which the font is entirely too small for most reviewers to read, and I have been told before that I can't read your font on your axes. So you live and learn. Here we go. Here it is. So if I just double clicked and this appeared. Okay. And this is the chart editor, so you can make some aesthetic changes and also some changes to how your data is being displayed. So right now I have 8, skip 10, 9, 10, skip 12, etc. Skip 11, 12. So I have every 2 years. If I wanted to double click on the axes, it keeps popping up on my window. Here we go. I can change that. So first I mentioned the size, so hey, I want it to be 14. Now, in everything you do, you have to click apply or enter on the keyboard. Anything in the chart editor won't save it. If I go into scale, I'll see the minimum and the maximum. So minimum doesn't really make sense to be 7.5. I know it's just doing this to show me the curve, but hey, if I didn't want that, and I just wanted to show the bars for the people I had in my study, in the increments, I actually want one for every year. I could do that, click apply, and it'll change my bar at the bottom. Okay. You can also, up in number format, you can add decimal places. It did not do this for years, but sometimes it'll give you like it'll be 14.0000. Like, I don't really need that. So you can take decimal points out here, use a scientific notation or not. You can take on grid lines. I don't like grid lines. So you can change these, or you can double click on the grid lines and new line. Right? Okay, you can double click on the bars, and now you'll have the color, the fill, and the border. So if I wanted to click, you have to click on each to set it. So fill, and I want them to be purple, my favorite color. Ta-da! Okay, so you can change things. You can also change the name of this over here. So if I wanted it to be, I just clicked twice. I clicked once slowly and then clicked again slowly. Frequency of whatever, right? Doesn't really matter. You'll see this is really small, so that when you're looking at this, basically, you can make assessments about what you need to change. Okay? One question I've gotten a bunch since last year is there a way to save these preferences in the syntax? As far as I know, no. If anyone finds this, please tell me. This would save me so much time in my life to be able to apply the same type of, formatting to many graphs at the same time. So if I'm just missing this, please let me know. Okay, you click and now it's out here in your input. You can copy. Right-click, copy, put it into Word, put it into whatever you want. You have a much nicer graph than the default. Okay, so that's just a little side deviation for the chart editor. We're almost done. I want to show you...
If you go back and you say you have to change some of your variables,
yes,
or whatever, will it automatically populate into, like...
this format of chart?
Yeah.
No. This is what's highly annoying to me. That's why I kind of recommend playing around and doing the fun stuff of the aesthetics once you're done. Like, if you have sort of a good idea and this is what you want to present to people or put in a poster or paper or anything, it's kind of usually one of the last things I do is to make it look pretty, because if you change things, again, as far as I know, there's not a way to really change this automatically.
Go back to the original.
Yeah. Any other questions? Okay. All right, next thing I want to show you is crosstabs. Who knows what crosstabs are? I did not know about these until way too late in grad school, and these are kind of a game changer. So, descriptive statistics and crosstabs. Oh, I see you this time. Here you are. Okay, so what this will do is it will break us down the data in terms of 2 different categories or more. So, just want to make sure I'm not forgetting anything. So it's for categories within your data. Say you want to know the accuracy by age and gender. So you wanted to know for the 14-year-olds how accurate they were, or the 14-year-old males how accurate they were, or any other variable broken down by category. So you want to move your variables of interest over into the rows and the columns. You're really going to be creating a table, and each cell in the table is going to be a frequency count or a mean or anything. We can specify what type of statistic we want in the cells. As a rule of thumb, I usually put the variable that has the least amount of levels in the column. That's just to visualize it better. So gender, for example, I'm going to do age and gender. Gender has 2 levels. I know there's 8 to 20 in age, so I'm not going to want this on the column. I'm going to put this in the row. That's just sort of a personal preference, but
Can you repeat that?
yeah, so if you have 2 variables that you want to put in, what's going to happen is you're going to get a table, right? You're going to get columns and rows. If you put a variable like age in the row, in the column, it'll do 8, 9, 10, 11, 12, all the way across, and it'll only have 2 here. It's a little bit hard to read because you have to like scroll over in the window. So a personal preference is to put the variable that has the least amount of levels. So female and male, there's only 2 versus, 12 in age, into the columns, and so it's going to be female, male, and then your age is down. Does that make sense? Okay. And then you could go into statistics. Hey, this is slightly annoying that it won't pop up on the shared screen. And notice chi-square, put a pin in this, we're going to come back to it, but this is how you would also get chi-square analyses. You can ask it for, instance cells, sorry. You can ask it for the counts, so how many times this happened, or you can ask it for a percentage. So it would be, in this case, we would have how many people of what age are in which gender thing, right? I said that wrong earlier. Let me clarify what I mean with crosstabs, because the next set is what I described before. Let me start that over. Crosstabs will give you a table, rows and gender, breaking up your data by categories. It'll tell you how many people are in each category. The next step can tell you of the people in the category, how did they do on the task. Okay, so first crosstabs is just going to tell you how many 14-year-old males do we have, how many 13-year-old females, none, because there are no 13-year-olds. Okay, and it can either give you the count or the percentage. Okay, so let's see, if we do a total percentage for each cell, click OK. Here we go. So, you know what, I'm going to do it without the percentage first to see what it looks like. This is a useful thing. This is recall recently used windows. So if you click this little button, it'll bring you to a list of what you just did, so you can go back to what you just did very easily. I'm going to take this off so we can see a little bit more clearly, and then we can put it back in. Okay, so here's the result. You have the 2 columns, female and male, and you have the age and years. You can see you have 1 male that's 8 years old, 0 female. Right? You have 4 female 9-year-olds, 1 male 9-year-old. And so if you wanted to break down your data that way, you could. If I go back now, I'm going to add cells. I'm going to say, okay, give me a percentage, like the total in that cell. And also, I can get a bar graph. So in, here it is, display clustered bar charts here at the bottom. If I click this, it'll give me the same table as I had before. Now I've asked it to give me percentages, right? So this accounts for the 8-year-old males represent 1.8% of our sample. And it'll give me this clustered bar chart. Okay, so now it's separating what I had before with that curve. I didn't add the curve on it, by female and male. Okay, can be helpful also. Now, to move to the next thing that I initially said, which is say, okay, now let's say I want to do crosstabs plus in a way. I want to know the mean value of a variable within each of these categories. So I want to know how they did on the task, right? We computed earlier an average accuracy for faces, average accuracy for voices. Let's see if I can see it by category. So what you would use is called aggregate, and it's in data, aggregate. And I'll bring this up here. So you can break on a variable. So hey, I want to break on gender. I want to know the males and the females, how well they did, right? It's easier to do it with one variable. Honestly, you can do it with many, but it was a bit easier this way. And I want the aggregated, I said average, right? Let's look at that. Average accuracy on the face task. And you can either say add it to an active data set, which I do not recommend, because then it's going to just append it to the one that you have. It's going to be confusing. I would say create a new data set. Or you can also write a new data file, but same thing. I don't know what the difference is between those two, to be honest with you. I'll have to figure out. And we're going to call it accuracy by gender. And I'm going to do OK, the name of it. Oh, I did not know that. You can't have spaces. Click OK. And now it will have given me, if I can pull it up for us, a new, here we go, a new file that only has those variables. Gender 0 and 1, and then I have the mean accuracy for gender, the mean accuracy for females and for males. So females did a little bit better. Notice that I cannot say that they did statistically better, right? We'll get into that in future meetings, but this is just kind of a descriptive variable. This is really useful when you have a really complex design where you have multiple cells. So for example, I have other data sets where you could break it down by emotion and also whether the face is looking at you or averted or how intense the emotion was. It was a 50% emotion, and then you have tons and tons of variable and you just want an average for that type of stimulus. This is kind of what it's useful for. Okay? Does this make sense to people so far? And, okay, last thing I want to show today, in the last 5 minutes. Any questions before I show the last thing? And aggregate? Yes?
Is there any advantage aggregating data as opposed to writing a t-test, or just it looks cleaner on your page?
So t-test is what I would recommend if you're doing this type of thing, where you just want to compare two groups. What I think aggregate is more interesting for, more helpful for, is for situations where you have you want a value for a cell in a really complicated, like within subjects design. So that becomes more helpful. We'll get into that a little bit as we go, but the idea being that if you have them do, you're seeing many different types of stimuli in an experimental task and you want to isolate response or response time to one type amongst many instead of going through and manually computing it, it's kind of a way to reformulate your data. And so it's a little bit more useful than in things like this. If you're just going to compare groups within your data, I would say use a t-test. Yeah. Which we'll do week 3. Okay. Anything else? Okay. Last thing. I'm going to get rid of this new one because it's not super helpful. If you wanted to compute a specific analysis for one group only in your data, so say you wanted to know the average accuracy or how many males there were within the control group, but not the epilepsy group. Anything where you need to only perform some operation on a subset of your variables, you would use data, select cases. Okay, and I use this quite often. I'm going to show you just based on this, but then I'll show you another, what I mostly use it for. So here, the most common thing is to do if condition is satisfied. So you click on the if, and it's basically telling you select my cases if what. Okay, so say I want to select based on the group, and I only want my controls, which are 0. Okay, so if group equals 0, continue. Output, filter out the unselected cases. So in this case, it will filter out not 0, i.e. 1. You can copy them to a new data set if you wanted to run a bunch of new things with just them. You can delete them, the unselected cases. I don't recommend deleting them because you might want them again later, right? So filtering out is a really useful thing where if I click paste, you can also paste this by the way, but if I click OK, it's going to filter out, put a little bar here through. Oh, it didn't work. Why? Because I had recoded it as 0 and as 1 and 2. Always check the resulting select cases for instances like this. Okay, so now my control group is 1. So, there you go. So now, everybody who had a label of 2 for groups, this is my epilepsy group that I recoded earlier into a new variable like I warned that we shouldn't. Here we have, we've filtered them out. So if I were to run descriptives again on them, if I were to get the mean age, it might be different than the mean age of everybody together. Okay? You could accomplish similar things in this case with the crosstab and the percentages and things like that. But what is also really useful is if you have a filter variable. So if you have people that you went through their data and for whatever reason, one common one in our lab is they moved a lot in the scanner, right? So their data is of poorer quality than everybody else. You still want to have them in your main data set, but you might want to run your analyses with and without them to see if it makes a difference, right? You could have people who didn't quite complete a questionnaire. You could have them as a filter variable. And so if we were to come in and say, insert variable, I'm going to go here, I'm going to call it filter. This is one that I commonly have in my data sets. Filter. You can say filter underscore paper, right? You're filtering them for this particular paper. Filter underscore incomplete data. You can describe what your filter is if you want, either in the name or in the label. You assign them a value. So I usually do 0 is retain, and 1 is filter out, and then click OK, and then go through your people and say, oh, for whatever reason it was, I'm kind of not making great examples right here, but you could say 1, 0, 1, 0, 1, and then you could filter out those people, right? Run your analysis with and without the filtered out people. So that's what select cases is most useful for, I think. If you have a reviewer, this is, well, what if you put in the people who, didn't fill in this questionnaire? Were they different than, or another good example is you had people come in for the evaluation, not everyone was eligible for the next step, and then the reviewer's asking you, were they different in terms of age or gender? But you could filter them out for your main analyses. They didn't do the rest of the studies, but then you still have them to compare. Things like that. Okay, we're just out of time now, and that's it. Just made it. Any questions before we go?
Can you do and or statements in your filters?
Yes, you can.
And
So
this space and then your other.
it will be the ampersand. And if you do ampersand, this is a really good question. To do ampersand, you've got to be a little bit careful. Where is it? Come here. So if you do and, group and age 14, it will only keep the group 1 and age 14, right? Now say we have one where we have scanners, different types of scanners. Say I wanted people who are on scanner 1 and 2 but not 3, and I wanted the group 1. So I'd have to do
Parentheses.
or scanner 1, and then or. You can't just do scanner 2. That's not going to work. You have to put your or, you have to do group equals 1 and scanner 2 again. So there are invisible parentheses here. You don't need them. But if you use an or, you have to repeat all the conditions that go into the second or. Does that make sense? Okay. Sometimes that's frustrating. But honestly, to check, you just have to go back to your variable and visually see if the barred out ones are the ones that you're intending, and that some of the ones that you wanted to keep aren't being barred out for no reason. And then, okay, here. So I didn't really use these at all, but they're all in your sides, and I just want to get to the last one. Here we go. So next week we'll do some stuff about associations among variables. We'll talk a little bit theory and then go through how to do a regression and correlation. If you have any feedback, please email me. There is that sign, which I really appreciate if you do the rate the speaker thing. But if you write comments in there, I'm only going to get them in a month. So they don't release them until a month after your presentation. So if you have any comments and feedback that you would like me to implement for the next few weeks, either stop by my office or email me, whichever one works for you. And please fill in the QR code evaluations. It's very helpful. Any last questions? Okay, thank you.
Thank you.
Stop this one.